Hello again, everyone. Today we're going to be talking about, or in this video, we're going to be talking about more linear equations and the graphs of linear equations. Specifically in this video about slope, with a focus on slope. So we are going to be making use of the slope formula, which we always denote. It's typical, and you'll see it, I'm sure, in the future as you go through more math classes, of the slope being denoted with the letter m. And it's the difference between the y coordinates of 2 points divided by the difference of the x coordinates of 2 points. And it also might be called the rise over the run, because when you're talking about rise, you'd go up or down, which is what the y value does, and then x is the run, where you're running either forward or backward, which is side to side, which is like the x-axis. So if we're trying to find the slope of the line through these 2 points, 1, 1, 4, and -3, 2, this would be our x1, this would be y1, that's 1 point. This would be x2, this would be y2, that's another point. So using the formula, we have m, the slope, is equal to y2 minus y1, so 2 minus 4, x over x2 minus x1, which is -3 minus 1, which is equal to 2 minus 4 is -2. -3 minus 1 is -4. These negatives cancel each other out, so we're left with 2/4 or 1/2. So the slope of said line is 1/2. Or the line that passes through those 2 points is 1/2, which means that between each point in the line, you go up 1 and over to the right 2. The rise is 1, and then you go over 2. Okay, so now we have to find the slope of the line through the points -8, 7 and -5, -9. Okay, so we have some other line that we're talking about. It goes through these 2 points, -8, 7, and -5, -9. So we have x1, y1, x2, y2. And then using the formula again, we have m, or the slope, is equal to y2 minus y1, which is -9 minus 7. And then x2 minus x1, which is -5 minus a -8, which would then make this plus a +8, which then equals -9 minus 7 is -16. -5 plus 8 is +3. So in this case, our slope of this line that we have that passes through those 2 points, between each point, we're going to go down 16 and then over to the right 3 to get to each next new point on the line. That's what the slope's telling us. The slope is the rate of change, which just essentially, in terms of linear equations, means it's the rate of it's the change between each point, like how far you're going down and over, or up and over, or up and up and down or over to get to the next point on the line. Okay, so now we have, that's not what I wanted to do. Thought I had the cursor. We want to find the slope and y-intercept of the equation of the line 3x minus y equals 7. Okay, well, this is a good place, I feel like, to introduce something new, but something useful that you'll see a bunch now. So we're going to take a quick segue over here. So there are a few different forms of linear equations you can see. The first one, which you've seen in the last video, is ax plus by is equal to c. For example, 2x plus 3y equals 10. This is a linear equation, and it's in standard form. There's some coefficient, and 10. There's coefficients in front of both x and y, and then they're equal to something. That's one form. This is standard form. The next form, one of the most commonly used ones that you'll see a bunch, is of the form y equals mx plus b. M is the slope, b is the y-intercept, which we talked about last time. This is very common, and it's named accordingly, slope-intercept form. And you can get here from standard form. Say we take this same example that we had before. And it's worth noting here that the only coefficient in front of x now is the slope. And y can't have anything or any coefficient other than +1 in front of it. And in this form, essentially, you're solving the linear equation for y when you go into slope-intercept form. So if we use the same example of 2x plus 3y equals 10, we need to solve for y. So we'd have 3y equals 10 minus 2x. So 3y then equals negative 2x plus 10, just to keep it in that form that we want. And now the last thing we have to do to get y by itself is divide everything by 3. So now we have y is equal to negative 2 over 3x plus 10 thirds. So now we have slope and y-intercept, mx plus b. We're in this form now. This is slope-intercept form. A last useful form, which is very closely related to slope-intercept form, which you can use, and we will use later, is y minus y1 is equal to m times x minus x1. If you'll notice, it's fairly similar to slope-intercept form. This one is called point slope form because you start with the slope m and some point x1, y1, that's where those come from, like a physical point. These, and then the other y and x are just variables. So this y, this x, they're variables, they stay variables, but you plug in x or y1 and x1 here, respectively. Then, in order to get to, or it's really easy to get from here into slope-intercept form. And this one is especially useful if you're starting with like a point in the slope and you don't have the intercept. So say you have a line with the slope of 3, and it passes through the point 2, 4. Say that happens and you want to get into slope-intercept form. Well, what we can do then is y minus 4, because that's our y1, is equal to the slope, which we know, of 3. And then we have x, our variable, minus x1, which is 2. And then all we have to do is just get y by itself, and then we'll be in slope-intercept form. But it's really easy because y is almost by itself now. It's just has something added, and we also have to distribute this 3 first. So we have y minus 4 is equal to 3x minus 6. All we have to do now is add 4 to both sides, so we have y is equal to 3x minus 2, and now we're in slope-intercept form. So now we know a little bit about the 3 typical variations of these equations. You'll see standard form, slope-intercept form, which is probably the most common and most useful to you, and then point-slope form, which is a good way to get into slope-intercept form if you don't know the y-intercept, but you know the slope and a point. So with that information, we can see that this is in standard form, and we want to change it into slope-intercept form because they asked us what the y-intercept and what the slope is, and we can find that if we know slope-intercept form. So we have 3x minus y equals 7. So we want to get y by itself. So I'm going to subtract 3x from both sides. So we have negative y is equal to negative 3x plus 7. Now all that I have to do is divide both, or all the terms by negative 1. So we're left with positive y, which is what we need, is negative 3 divided by negative 1 is just 3. So 3x minus 7. So now we can see that our slope is 3 and our y-intercept is negative 7. Because it's in slope-intercept form, now we know those. Okay. So now, and the reason I had to introduce that is because otherwise we really don't have much to work with here. We don't know, we don't know how the points change. Like in here, we can see the rate of change because we can see how y changes with relation to x, which is what the slope is. And we can easily see here that if we set x equal to 0 to find the y-intercept normally, we'd find it immediately. It'd be negative 7. So that's why we have to, that form's really useful. And that's also why we needed to use it there, because we don't have any other information really to go off. If we don't have the 2 points to find the slope, we don't have the, the other tools to find the intercept. If you find the intercept, it'd be, you wouldn't really know anything about the slope without changing its form, without changing the form of the equation. So same type of thing here. We want to find the y-intercept and slope of this equation, which I'm going to just write. Oh, that's a highlighter. Still, it's not in the proper format here. Okay, so I'm going to write this as for y is equal to x plus 9. This is almost there. The only thing we have to do is divide all of the terms by 4. So we're left with y is equal to, well, the only coefficient in front of x is 1, so it'd be 1/4 x plus 9/4. So our slope then is 1/4, and then our y-intercept, or b, is 9/4. So we found those again. And that one was pretty simple there. Okay, here is another one that is in standard form, and we need it to be in slope-intercept form. So once again, if we want to go from standard form to slope-intercept form, just solve for y. So we have 2x. I don't know why this keeps cutting out like that. 2x minus 3y equals 6. We want to start by subtracting the x, or the 2x. So we have negative 3y is equal to negative 2x plus 6. Now the last thing to do is divide everything by negative 3. So we're left with y, negative 2 divided by negative 3 is positive 2/3. X, And then 6 divided by -3 is -2. So then this is our slope. This is our y-intercept. So our slope's 2/3, our y-intercept is -2. Okay, the next one is a really good example of why it's useful to have point slope form, because we are given the slope and a point. So now we have y minus y1 is equal to m times the quantity x minus x1. So y is the variable, so it just stays variable. Y1 would be -7, so we have minus a -7 is equal to, the slope is 3, and then we have x minus x1, which is just 0. So now we have y plus 7, because minus negative is plus positive, is equal to 3x minus 3 times 0, which is just 3x. So now all we have left to do is add 7 to both sides. So then we have y is equal to, subtract 7 from both sides, is equal to 3x minus 7. So that's the equation of the line with a slope 3 and the point that passes through the point -7. Technically, you could stop at this step and just leave it at y plus 7 is equal to 3x. You could if you wanted to, which is just fine. That's still technically the equation of a line that has that slope and passes through that point. But slope-intercept form, the one we got to down here, tells you a little bit more, and would allow you to graph it more easily if you had to do that as well. So it takes like one extra step, and it can be useful. Same type of idea here. We have a slope and a point, so we want to use point slope form. So we have y the variable minus y1, which is minus a -3, equals -3/7, because that's our slope, times the quantity x minus x1, which is 4. So then we have y plus 3. We're going to distribute this -3/7. So we're going to have -3/7 x. And then -3/7 times -4 is a positive 12/7. And then I'm going to add 3 to both, or I'm going to subtract 3 from both sides. So we're going to have y is equal to -3/7 x minus 9/7. So there is our equation of the line that passes through the point for -3 with the slope -3/7. Okay, so the next one is similar. It's just one added step. We have to find what the slope is first, which isn't too bad. We can do this. So we have the slope formula, m equals y2 minus y1 over x2 minus x1. So we have the slope is equal to, y2 would be 20, x2 would be, or I'm sorry, y2 would be 20, y1 would be 6. We have 20 minus 6 over 3, because 3 is x2, minus a -4, which is plus a positive 4. So 20 minus 6 is 14, and 3 plus 4 is 7. So 14 over 7 is 2. So our slope is 2. And then now we can use point slope form. Just pick a point. I'm going to pick 3, 20. So now we have, in point slope form, y minus y1, which would be 20, y minus 20 is equal to 2 times x minus x1 in this case, which is 3. Not to be confused when we are doing the y2, y1, x2, x1 over here. That just denotes that we have two different points. In either order that you pick the points in, you'll get the same slope, and it doesn't matter. And either point you pick for point slope form will make it work too. I just picked 3, 20 because they were both positive. That's the only reason. It won't make any difference either way you do it. So we're going to have y minus 20 is equal to, we're going to distribute this 2 is equal to 2x minus 6. Then all we have to do is add 20 to both sides. So we have y is equal to 2x plus 14. So there we go. Perfect. That is the equation of a line that passes through those points. We found the slope, we found, or we had a point, and then we found the equation. So now, same thing, again, we have to find the slope first. So y2 is -3, y1 is 6, so we have -3 minus 6. X2 is 7, x1 is -3, so we have minus a -3, which becomes plus a +3. So -3 minus 6 is -9 over 7 plus 3, which is 10. So we have -9/10 for the slope. And then I'm just going to pick this point to use for point slope form. So we have y minus 6 is equal to -9/10 times x minus 3. So we have y minus 6. We're going to distribute this equals -9/10 x plus 27/10. So then when we add 6 to both sides, we have y is equal to -9/10 x plus 87/10. And there is our final answer. Okay. Okay, so now for finding the equation of a horizontal line, one thing to note about the slope of a horizontal line is that it's 0, because if you think about it, if a line's horizontal, you're not gonna do any rising or falling, like you're not going anywhere. It stays, it stays at the same y value all the time. So no matter which 2 points you pick to calculate it, the y value is going to be the same. Or in other words, y2 is going to equal y1. So your y is going to be 0, and then whatever the other x's are doesn't matter, because if you have 0 in the numerator, you're going to have, it's going to make it the whole thing 0, because 0 divided by anything is still 0. So the slope for any horizontal line is going to be 0. So when you have this, the only thing you need to be concerned about is the y value. And since the slope is 0, if we think of our point slope form, we're going to have y minus 51 is equal to 0 times x plus 23 in this case. This is going to be 0. So we just have y is equal to 51. So that's our equation. And that'll be the case for every single horizontal line. The slope is always 0. So if they ask you to find the equation of a horizontal line that passes through some point, it's just going to be y set equal to the y coordinate, because if it's a horizontal line, it's never going to, the y coordinate's never going to change no matter what point you hit. Okay, now in a somewhat similar spirit of find the equation of the vertical line through the point 23/51, negative 23/51, vertical lines are always going to have an undefined slope, because you're going to have y2 minus y1 for finding the slope here, but in the same token, x2 is going to equal x1 in this case, so the denominator is going to be 0, because if it's a vertical line, you always have some rise, but you don't have any run. You don't go side to side at all. It just stays in the same place, the same vertical place the whole time. But you can't divide by 0. That's not allowed, and it doesn't give you any solution. So we always say, or you'll always hear too, that the slope of a vertical line is undefined, because it's it's infinite technically. It's you can't define it. So the slope is undefined here. So what you do for the equation of vertical lines is you just set x equal to the x coordinate. So in this case, it'd be x is equal to negative 23. Because it's what that's saying is that here you only have a vertical line that crosses through, or you only have a vertical line, and the x coordinate will always be 23. There will always be negative 23, and the y coordinate will can be anything else as long as the x coordinate is negative 23. Okay, so are the following lines parallel, perpendicular, or neither? Okay. So in this one, or in the next few, I should say, it's good to note that parallel means that the lines have the same slope. Perpendicular, opposite, reciprocal. Slope, which means, say you have a slope of 1/2 for one line. That would mean that the perpendicular line, the line that is perpendicular to this one, would have the slope 2/1, because that's reciprocal, but negative. So it'd be -2. So that's what it means to have an opposite reciprocal slope. And then if they're neither, then neither of those two cases happens. So what we're going to want to do here is make sure they're both in slope-intercept form, and then just compare what the slopes are and see if they fall into any of these categories. So this one's already in slope-intercept form, so we just have to worry about this. 2x minus 5y equals 10. So we're going to have negative 5y is equal to negative 2x plus 10. Divide by negative 5 on both sides. So we are by all the terms. Negative 2 divided by negative 5 would just give you 2/5 x, and then minus 2. So it doesn't matter what the y-intercepts are. If they're the same y-intercepts and the same slope, then they're the same exact line. So you don't have to worry about the y-intercepts. We're just really concerned with what the slope is. So we have a slope of 2/5 and we have a slope of 2/5. The slopes are the same. So these ones would be parallel lines. Okay, so are the following lines parallel, perpendicular, or neither? Same question. Okay, so here we're going to also want to change both of these into slope-intercept form. So for the first one, we have -7y is equal to -5x plus 1 divided by -7. So then we have y is equal to positive 5/7 x minus 1/7. So the slope here is 5/7. And then for the next one, we have 5y is equal to -7x plus 1 divided by 5. And then we have y is equal to -7/5 x minus 1, or plus 1/5. So if you compare these two, we have 5/7 and then -7/5. Well, 7/5 is the reciprocal of 5/7, and then the opposite of that would be -7/5. So this is opposite reciprocal. So these two lines would be perpendicular, which means that they intersect each other at a 90-degree angle. Okay, and then are the following lines parallel, perpendicular, neither? Well, once again, we just have to change them into slope-intercept form to compare the slopes and see what we end up with. So we're gonna be, for the first one, we have -3y is equal to -2x plus 6. So then we have y is equal to 2/3 x minus 2. Here's our slope. Then for this one, we have -2y is equal to -3x plus 6. So y is equal to 3/2 x minus 3. So if you notice here, we have 2/3 compared to 3/2. The slopes are reciprocals of each other, but they're not opposite reciprocals and they're not the same. So these ones are neither parallel nor perpendicular. Okay, so it says to graph the line below using only the lines slope and y-intercept, you would use the lines, or you'd use lines y-intercept 0, -2, along with which additional point? Oh, hold on, it doesn't. One moment, just one moment. I think the slope may have gotten. Oh yeah, I'm sorry about that. That was not intentional, but the slope that they were going to give us was cut out of here. So the slope is supposed to be, hold on one sec, sorry, just one more moment. I have to double check to make sure I'm looking at the right thing. Okay, yep, that's what I thought. Okay, so the slope is supposed to be 3/4. So our line would be y equals 3/4 x minus 2, because it gave us our y-intercept. So if we were graphing this, so in order to graph a line like this, with just the slope-intercept form equation, we know that the y-intercept is -2, which is the point where the y-intercept, or where x is 0 and it crosses the y-axis, the vertical axis. So it would, oh no, that wasn't quite right. Oh, that also wasn't quite right. There we go. That's better. Okay. So that would be this point right here. And now what we want to do is use the fact that we know that slope is rise over run to go there, or to go to the next point. So what we're going to do, since it's +3 over +4, the rise is positive, so we're going to go up. So we go up 1, 2, 3. So that'd put us right here at 0, 1. Then we're going to go over to the right 4, which is 1, 2, 3, 4. So the next point is going to be right here, which, if you count, is at 4, 1. So this would be the additional point we would use um, to find it. And that's how you'd graph the line. So you would, in order to graph that line, you only need 2 points. You'd start with the one we're given, and then find the other one with, start with a y-intercept always. Use the slope, the rise over run, to find the next point, and then draw the line. So that's all you have to do for that. And I hope that was helpful. I will talk to you guys in the next one. Thank you.